Is this better? Can you see my screen now?
Yes, just you'll have to go to full screen.
So if I go to full screen, then I will not be able to see the other window.
Okay.
If I do
Uh,
this. So
we,
I mean,
oh,
if anyone is waiting to join, I wouldn't see that because I'm sharing the whole screen.
okay, you go ahead, and if you're doing that, I will let them in. Vivek, you should be able to let them in, right? On the side, if you go click on people, if you have people joining in, you should be able to just let them in.
I am a guest only, I believe. I don't think I can allow.
Okay, let's go ahead. I think I should be able to manage. Just go to full screen, Sir. I'll admit all in one go.
Yeah.
Yeah. Uh, Welcome everyone. First of all, thank you for registering and wanting to be part of DVCon Design Verification India 2023 Design Contest. My name is Pradeep Sala. I'm the General Chair for DVCon India 2023. We also have Seru Srinivas, who's the Design Contest Chair, and Dr. Vivek Chaturvedi. He's from IIT Palakkad. He's the Academia Collaboration Chair. And we should also have Professor Subramanian Mula, and who's also an academic collaboration chair, and also a professor at IIT Palakkad. We will also have Upul Iknaika, who's from Sri Lanka. He's the Sri Lanka liaison chair. He's helping us with reaching DVCon into Sri Lanka. So first of all, a warm welcome to all of you. Uh, so what we will do today is I'm going to quickly give you a quick overview of what DVCon India is, and what's the origins of it and what's our charter. And then Seru is going to talk about our design contest, and then Professor Vivek Chaturvedi will take on the problem statement. We are currently recording this, and the idea is to get this uploaded on a website or YouTube so you can have access to it later on. And so with that, so design verification conference has been around since 2014. Primarily, we were focused on industry. So it was basically a technical platform for the industry to contribute new ideas, talk about collaborating on new standards, working on methodology, flows, especially for the digital or analog design and verification. That used to be the primary focus. And it also helped generate demand for our sponsors and participating organizations because it would help them develop markets and for their products and services. But then, a while back, we said we need to expand. Now that we've established ourselves, we wanted to, bring in and get academics part of this, conference. And we've been doing that for the past couple of years. Last year we had a hackathon, and this time we are for the first ever time we are doing a design contest. So what's in it for an academic at DVCon? So basically, it's an opportunity for you to learn the latest developments and trends, learn from the industry, experts that are out there who are going to be presenting papers. It's all about knowledge sharing, right? That's what we are looking at. And also, it's just not for you to learn knowledge sharing. It's you put out your thoughts and ideas and share your experiences. So in that process, you get better at it. So it's all about ecosystem networking as well. Next slide, sir. So, there are two things. One is Accelera. Accelera is an industry standards body, and the DVCon was born out of Accelera. So Accelera, has been sponsoring DVCon for the last 30 years. Initially, DVCon had various names. So if you see the graph there, initially it was, there was a conference for VHDL users. Then we had an Open Verilog International conference. So eventually they merged together in 2003, and the name was called DVCon US. So The name DVCon US has been around since 2003, so it's almost 20 years. But prior to that, about 10 years before, a little longer, it existed in different forms. DVCon came to India and Europe in 2014. It started off in China in 2017. Then now it's there in Japan. And 2023 is the first year for DVCon Taiwan as well. So it is expanding worldwide. Um, Again, the whole idea of DVCon is no matter where it is, the look and feel is the same. The base, the core of what DVCon stands for is the same. But each region brings its own flavor and different charters. So I'm proud to say that hackathon was done for the first time ever, and this team was pretty much there, enabling that, making that happen last year. And this year we are doing a design contest, and this is unique to India. You won't find a hackathon or a design contest anywhere else in part of the world. So that way we are all unique. So congratulations on being a part of a unique program in DVCon India Design Contest. Next slide, please. Yeah. So what is Accelera Systems Initiative? So these are some of the outputs out of Accelera Systems Initiative: the portable stimulus standard, most importantly, System Verilog VHDL, UPF, System C, UVM. These are all products of the Accelera Systems Initiative, whose mission is to provide a platform in which the electronic industry can actually collaborate and innovate and deliver global standards. So that way, everyone across the industry, once you have a standards, it's easy to do plug and play, and that's the whole goal, especially focused on improving design and verification productivity for electronic products. So just to let you know who are all part of this Accelera initiative. So if you see, it's a big list. The who's of industry is there. They're segregated into corporate members, associate members, and the startup and universities. I'm not going to mention all of them. I'm just going to give it a couple of seconds for you to look at it before we move to the next slide. Next slide, sir. So the way Accelera is organized is there's a board of directors, and then you'll find different committees. So there will be a technical committee, there's administration and promotions committee, and there's an extended kind of a dotted line, which is the IEEE working groups as well. Under the technical committee, you will find different working groups whose charter is to standardize. So if you see, those are the ones that are existing. So each one is a working group. So we have a working group for IP Exact, one for UVM, one for portable stimulus, one for functional safety, one for IP assurance, one is for multi-language. So if you see, there are multiple standards, and each one has its working group, which is industry experts coming in from various companies, putting together and trying to put the heads together to make sure that we have a common usable standard to solve each one of those problems, right? Next slide, please. Again, this is just a bunch of current standards and supplemental material that's available. You just have to go to accelera.org and you'll find all of this. Next slide, please. And we do have a strong partnership with IEEE. So if you see, there are a lot of IEEE standards which are free to download. So they all started off with Accelera initiatives, working group projects. For example, UVM, UPF, System Verilog, or System C, they all started like that. And now, once they have matured and there has a strong adoption, they've all become IEEE standards. So right now, we've gotten a bunch of them standardized. We are working on a whole bunch of other things to get them standardized. So there is a very strong partnership with IEEE and Accelera. I think with that, you can take over, sir.
Yeah, thank you, Pradeep. Hi, good afternoon, everyone. So welcome to this design contest rollout. So as Pradeep mentioned, we are quite a few companies who have come together along with Axilera to bring this DVCon to everyone in the industry. And this year we are going ahead with a design contest for all the academia, and this is going to increase participation from the academics and universities. And this is the first time that we are organizing a design contest in 2023. So this is mainly to give a good opportunity for all the students, and especially this particular design contest. This is going to be a risk-free based architecture, and the applications on that. So this will help you deepen your understanding on this risk-free and risk-5 architecture and applications. And you can explore the design verification space, which is our theme here, and how to improve the performance of this. You will get to implement your own processor core using industry standard FPGA. You will also get opportunity to interact with experts from industry and academia. This will also have, as you would have already seen, we have good cash prizes, and the winners or the participants also will get an opportunity to get picked by leading VLSI companies for internship with their organizations. And this is also a great networking opportunity for you all with the mentors, with the other participants, etc. Okay. I would like to also tell you that we have great design contest mentors here who are going to be working with you and helping you out. Dr. Vivek Chaturvedi, Dr. Subramanya Mula, and Upul Ekanayaka. You will have the opportunity to talk to them, understand what this design contest is, take their help, take their mentorship in bringing your design, the problem statement into life, and understand a lot more things that are going behind it. Okay, and so over to Dr. Vivek.
Yeah, thank you, Sri. So first of all, let me just mention here that we have this alias email that you can see over there, right? DVCon India Hackathon. This is the one which you should use to reach out to us for any of your queries while you are, working on your designs. Okay. Okay. All right. So now I'll just share my screen and roll out the design problem for you all. Okay.
Yeah, go ahead, Vivek.
Okay. So is it visible?
Yes.
Okay, wonderful. So first of all, it's almost about evening, so a very good evening to all of you and a very warm welcome to the design contest DVCon India 2023. And let me first thank you all for participating because we have received a very nice turnout. So we are really very excited. Okay. And I believe all of you, since you are working into this area or you have some exposure to this area, most of you must be aware of the fact that RISC-V recently has been, growing very popular, and its adaptation in the industry and academia is growing very rapidly. Okay, so that's the reason why this year we thought that okay, our design contest should be based on, RISC-V code. Okay, so in this contest, basically there are first of all few important things. So there are two stages of this contest. Okay, stage one, we call it as a design proposal contest. Okay, it's starting today and the deadline for it is 1st of June. Okay, so this is a selection stage. This is a selection round for stage two. That means all of you are going to do your submission for stage one, and few of you are going to get selected for stage two. Okay, and the stage two, what we are going to have more of an implementation and verification of whatever you have proposed in the stage one round. Okay. So as I said, this contest is basically based on RISC-V. So what we are going to do is we are giving you or we are providing you with a base design already. Okay. So what we are going to use here is a is a very well-known open source platform, which is Pulsimo. Okay, this is the microcontroller architecture Pulse chip. Okay, and this is basically the product which is being developed in the collaboration of UTS Zurich and University of Bologna. Um, and as you see over here, this diagram basically shows you the overall architecture of Pulsimo. Okay, so
Vivek,
yes.
Vivek, do you just want to zoom in a little bit more?
Yeah, I can do that. Yes, 1 second. Yeah, so this is basically the main architecture diagram of the Pulsimo SoC. Okay, and what we want you to emphasize this time is that we are going to give you application, and we want you to improve the performance of that application on this particular platform. Okay, I'll get into a detail of this platform slightly later, but let me just briefly tell what this problem statement is about. Okay, so basically we are going to give you an application, and you have to improve the performance of that application on this given platform. And if you see over here, there are two main blocks that probably you have to work with. One is the RISC-V core, and the other is the hardware processing engine, which is HWPE. Okay, so essentially, what we're going to do is, so let me say it this way. Okay, so let me first go to the stage one problem description. Then I'll go through what are all the different source file for this particular platform. Till now, any questions for me? I mean, you understood there are two stages: stage one, stage two. Stage one is a design proposal stage, starting today, ending on 1st June, and stage two will start on 1st June and will end on 15th August. Okay. All right. So in the stage one, basically what we're asking you is to prepare a detailed design document, which is going to contain an architectural level description of whatever the hardware level design optimization that you want to propose, which can actually enhance the performance of mobile net V1 application that you're going to run on Pulsimo. Okay, so what we are giving you is a Pulsimo platform and the mobile net V1 application. What we want you to do is improve the performance when you are going to run this on the platform. What you can do to achieve your optimization, some of the suggestions that we are giving you up front are, maybe you can improve, maybe you can add more pipeline stages to the RISC-V core. Maybe you can introduce some new instructions. Maybe you can modify the existing hardware accelerator, or you can introduce a new hardware accelerator, or maybe you can think about adding more functional units which you think are suitable that can improve the computation time of mobile net V1. Okay, so over here, let me just quickly go through some of the steps that you have to complete for stage one. First of all, you have to download you have to just go through the entire package of a Simo platform. You need to go through the documentation. You have to really go through well the tutorials so that you can understand what, first of all, it's a very comprehensive architecture, right? A very comprehensive platform. So you have to go through all documents and tutorial very carefully, and then understand what this entire ecospace is about. And then you can, based on whatever you have read, whatever you have watched, and of course, you're going to explore the design files and everything. Based on that, you have to propose what kind of design optimization that you wish to propose, which can help to improve the mobile net V1 performance here. Now, performance again could be in terms of throughput. It can be in terms of latencies. It can be in terms of the inference time that you see that you are going to calculate for mobile net V1 application. Yeah, the document that you are going to submit, okay, should contain a very detailed architectural diagram after whatever the modification you are suggesting. It should also contain a verification plan. So as you understand, because you're going to do some changes in the design, you have to also suggest how are you going to actually verify or validate that whatever the changes you have made, after that your design is working perfectly fine. Okay. You also have to tell us what are the different types of tools that you're going to use to achieve your implementation. Some of the important notes that probably you have to keep in mind. that whatever the optimization that you are suggesting should be based on certain trade-offs that you are looking into. So if you're improving performance, what is this trade-off with the design complexity, right? Or how much is going to impact some power or energy consumption? Moreover, you know that after this stage one, you have a stage two ahead of you, right? So you have to make sure that whatever the plan that you're proposing in your document should be a feasible plan, and you should be able to achieve it within the 2.5 month timeline. Most importantly, your optimization should be majorly focused on design. Okay, we don't want you to do too much modification at the application level. So that means for the mobile net V1 application, we don't expect you to do too much compression of optimization in terms of compressing the model, apply pruning or quantization. Already some quantization has already been applied in the application which we are going to give you. Okay. Again, the final submission is going to be a 5-page PDF only. So we have restricted your submission into 5 pages. Your verification plan can be just 1 page within that 5-page limit. Okay. Next, we have our evaluation criteria. So whatever the novelty you are proposing, we are going to mark it for the 60% of the marks. Your verification plan will consist of 20% of the marks, and how you have written your report will again consist of 20%. So please make sure that your report is very precise, and whatever optimizations that you are suggesting, you also have to write your rationale behind it. Like, why did you think of proposing a certain optimization? So for example, you want to, let's say you want to add some let's say some floating point unit or something. So why do you think that floating point unit should be part of this design? Okay, so that rationale is very, very important, okay, when you are writing your report. All right, so now let me just quickly go through the the main files that the main resources that you probably have to utilize when you are trying to work on the stage one of this design contest. So before I do that, any question on the problem statement or anything on that line? uh, any questions? Okay.
Do the tools need to be open source?
So I'm going to tell you what tools you're going to use. The tools mostly they are open source, and you can use it easily without any problem. Any other questions? Okay, so probably then I can just quickly go through the main resources that you probably have to utilize. First is the tutorials. So we have given you the link for 2 different tutorials which are very comprehensive. So if I were you, I would have first gone through the tutorials first. Okay, so that's my suggestion, that you should first make yourself familiarized with the documentation and the tutorials which are being provided to you. Once you understand this tutorial, then you will understand the comprehensiveness of this platform, and also you will get awareness to what kind of changes probably which are feasible within this platform and how to make those changes. Okay, so therefore the first thing is you should please go diligently go through the tutorials and try to learn about the entire platform. Okay, once you are aware of that, then probably the next thing that you have to do is you have to uh, do some initial setups. So typically, most of the time we have seen that people tend to ignore this part. But probably when you start your setup, please begin with setting up the GCC toolchain first. Okay. Once you are done with this, then you can choose what kind of a platform you want to use. For stage one, you probably have to use something called as a GVSOC, which is the virtual simulation platform for PUL. Okay, I'm going to go go through all these links one by one, but just wanted to go through all the points first. And then the application which you have to use is also available, and it is MobileNet V1. Okay, So let me just quickly show you the main pulp GitHub. So is the GitHub available, visible to you all? Is it visible?
Yes,
So,
it is visible.
Yes.
Yeah.
Yeah, so this is the main pulp Simo GitHub. Here you can see all the relevant files, the RTL design, the software releases, everything is provided here. If you go through the README part, okay, it will discuss about the main architecture. So basically in Pulsimo, if you see the main architecture block, you have the RISC-V core and then you have the hardware processing unit that probably you have to majorly work on in terms of improving the performance. Okay, I don't think that you should look too much into any other kind of modification here. So within this, if you think there are two types of cores which are part of this platform. One is the risky, which is an in-order single issue core with 4 pipeline stages, and it has some more support for Mac and floating point. And then there is another core which is IBEX, which is a zero risky core, again an in-order single issue core with 2 pipeline stages. So please note, in this contest, you have to use IBEX core. That means when you are selecting your design files or whatever, you have to select files which are related to IBEX. Okay. When you go through the tutorial, you will see that how you are going to do it. But please keep this in mind that whatever optimizations you are suggesting for this IBEX core. Then if you come down, there is also discussion on what this hardware processing unit is, and also in case you want to modify this hardware processing unit, or you want to add your own IP of a hardware processing unit, all that information is also available in the document which is associated with this. Again, the tutorial that you have mentioned in the main problem statement document, the link is also given over here as well. Okay, so over here you can, if you go through the entire documentation, you will understand how exactly you have to work with this platform. What are the things that are feasible in terms of design optimizations, how you are going to actually achieve it, how you are going to add your own IP, how you are going to access the application and also run that application. All that information are given in this GitHub repository, and specific links we have already provided in the document which we are going to share with you. Okay, right. So this is again the link. If you want to perform the RTL simulation, you can use Questa Sim, and Questa Sim is the tool which probably for now, if you want to use, you can use it through EDA Play Store. But probably for stage 1, the main focus should be on using the virtual platform. Okay, which let me just yeah, this is the part where probably you will be dealing more with this. So this is the one which you are going to use, which is GVSOC, and the link and the material, everything is provided in this GitHub for it. Okay, so I think probably with this I can stop here, and if you have any questions, please feel free to ask me now. Otherwise, the alias email that we have provided to you. Please feel free to send your queries over email, and we'll get back to you.
Okay. Hello, sir. So
Yes.
basically, are there any HDL constraints as well while the design process we are implementing?
So here the entire design is based on system Verilog. Okay, so that's what
Okay.
you have to probably utilize.
I think the design would be in Verilog or system Verilog, the design language, and the test bench would be in system Verilog.
Yeah.
And also I see some questions. So what we will do is this design document will be posted online and a link will be shared, or we can just go ahead and share this design document with you. Shouldn't be a problem. We'll go ahead and email it to you.
There's just one request I want to make, that once you read the design document, before sending your queries, I request you to first go through the documentation and also at least watch one tutorial. Okay, because a lot of your doubts will really get clarified once you watch those watch those videos. Okay, after that, whatever doubts you have, please feel free to email us and we'll be more than happy to assist you in that. Okay.
Hello, sir.
Yes.
Sir, most of us or some of us are in fourth year of our college. So by the time the competition happens, we will be in companies, maybe probably in companies. So is that a problem? I mean, right now we are in college. So by end of May or June, the fourth year students will be out of the campus. Right?
We'll look at it a case by cases. For now, it should be okay.
Okay, sir.
Any other questions? Okay, I think
Also,
there are no other questions.
let me just add
Yes,
one thing,
Vivek.
Cyril. Sorry. So also regarding the tools, once you go through the tutorial, you will also know that what tools are actually that you can use without a problem. Okay. So those queries can also be sorted out if you just can go through the tutorial.
So do we have access to this recording of the current meet?
Yes, we will post it. We will have this on some link. We'll provide a link or a YouTube. We'll upload it on YouTube. Just give us a couple of days.
Okay, so thank you.
I think Vivek, there is a question in the chat. They are saying, do we have to change anything in the architecture of MobileNet V1 for implementing on the RISC-V?
Yeah, we don't encourage any changes on the application part. Okay. But if there is,
Yes,
if you think that it's really necessary, then you can give a proper rationale for it and then tell us. But I don't think you'll require that.
correct. Yeah.
Sir, what kind of parameters you mentioned the latency and throughput, for example, what other parameters or how many parameters will the design efficiency be judged?
So we are not very specific on that. You may please, based on whatever your understanding is, you please propose how you are, uh, how do you define the performance for this application and how you are going to improve it. Okay.
And is there a cost constraint as well?
No, not in this case. I mean, not now, not for stage one at least.
Okay,
but the only
thanks.
thing is the whatever you are suggesting should be feasible. So we have already mentioned the trade-off that you are looking into, right? So you can look into those trade-off, and also you should see that whatever you are proposing is feasible within the stage 2 timeline. It should not be too ambitious. Okay.
Okay, thanks.
There is a question on the last date for document submission. So Vivek, you want to take that?
Yeah, it's 1st June. So I think that detail probably again we'll send you over the email.
Vivek, I see a question on no discussion forums. What we can do is we can set up a discussion forum on Google, and that could be enabled for group discussion. Just give us that's something that we are looking at. We'll get back to you with that.
Okay.
Okay, looks like there are no other questions. Pradeep or Vivek, do you want to add anything more before we close?
No, nothing from my side.
Okay, Pradeep, do you want to add something?
No, I think again, this is a great opportunity for all of you, and we've spent a lot of time, and before giving it to you, this has been tried and tested by students, and then only then it's been given out. So it's something that we've already done. So please do make good utilization of this opportunity. And like Vivek said, please just don't reach out to us, with simple things. We would request you to go through the tutorial, spend some time. A lot of your questions would be answered there, and then at least set the flow up, and then we can help you with your questions. So we will try to schedule, Vivek, we will try to schedule some mentoring sessions, fixed time slots, right? Like this, and then we can do a live Q&A during these before your deadline as well. So I think we will set those up, mentoring sessions. Maybe we'll tell you the frequency, so we'll be able to answer some questions for you as well. And we will create some kind of a discussion forum for you to post your questions.
Yeah, thank you, Pradeep. So we will be sharing the document with you as well as the recording of this, so you can go through that. The problem statement document, what Vivek showed, that will be shared with you all. That will have all the links on where you need to be reaching out and where you need to look for the videos and tutorials and all of that. So as Pradeep said, please make sure you are going through all of that before you pose your questions to us. Okay, and looking forward to a good participation, and we will have our first stage 1 by beginning of June, that is 1st June. And the second stage, we will let you know who all are selected for the stage 2, which we are expecting to be completed by August 15th. Okay, if you don't have any other questions, then we can close this.
Thanks, everyone. Thanks, Siru.
Hello, sorry, sir, to interrupt you. I have one question. I'm currently in my 4th year of college, and I'm doing currently internship also. So, is there any problem with this particular DV contest?
No.
Okay, thank you, sir, for answering.
Okay, thanks, everyone.
Thank you all.
Okay, thank you, everyone. All the best.
Bye.
Thanks.